Guys, we'll be starting shortly. Please hang on. So we will be starting in 5 minutes. Uh, Guys on YouTube as well, we will be starting shortly, and please hang on right now. Hello everyone. How is everyone on YouTube and Teams? Hope you guys are well and are safe at your homes. Guys, everyone who is joining right now, we are going to be starting the session soon, so please hang on right now. Once we have some people joined in, I will start the session. So hello everyone, who has joined right now. Hello guys, who have just enter the meeting. We will be starting in 1 minute. So welcome to the DevCamp's 2CC sessions. So we are starting shortly. Stay tuned. Excuse me. Hello everyone, we will be starting the session now. So my name is Mayank Kumar and welcome to the DSC-VIT's 2CC session. So let's start with the 2CC session now. So today's topic is FastAPI. Then before I start the 2CC session, I will like to tell you about some things. First, I would like to tell you about the 2CC session and then we will be going on with the topic for today. So about the 2CC sessions, it's going to be a 1-year course. So you will be requiring to submit one project at the end of the course. And that's it about it. And we will be sharing you all the links and the details during the sessions. So you have to RSVP to all the links, and the more details about the project will follow in the next coming up sessions. So let's start with today's topic now. Let me start by sharing my screen. Okay, so I guess we have the screen. Okay. So let's start. Today's topic is backend development with FastAPI. So let's look at what are the topics that we are going to cover today. So we are going to be covering what is the backend development, what is HTTP, and what is a DBMS software. First, I'm going to introduce you to these topics. Then at the end of this presentation, I'm going to start with a project for you guys. The project is going to be about making APIs for a blogging website. So let's start with that. So first thing I'm going to tell you about what is a backend. So most of you guys must have seen or used web applications. So a web application is going to have various components to it. The most common components are a website, an API server, and a database. Okay, and the website is served over a web server. So let's understand it. What are these components, and which of these components are grouped together into which groups? So talking about front end, anything with which the user is interfacing with is the front end part. The user side thing, that is what is called a front end. So what is a backend now? So a backend is anything other than the front end. So backend is going to be isolated from the front end side. So let's see in this diagram, we can see that there is an API server and a database. This part, which is not interfacing with the user, that is actually the backend. So a website is going to be sending HTTP requests to the backend, and the backend is going to respond with a HTTP response. Let me help you guys in understanding this better with an example, a real life example. So let's say you are tasked to make an architecture for a survey app for an awesome store. Okay, so the awesome stores requires you that you make a website where the user fills in their name, their age, and the feedback, and you send this feedback to the server, and the server saves it in a database. So we can see it here that there is this website, and this website is sending in requests to the API server, and the API server is responding with a response. So what did the API do? API server do? API server got the request. It understood that it has to do something, and how it understood what it has to do, I will tell you guys about it in the next few slides. So the API server gets to know, okay, it has to save this response. So it saves in the response and sends back a message. In the message, it says, hey, it was successfully submitted. So this is how backend server works, and this is what is a front end. This is what is backend. Now let's look at a real life example now. So let me show you guys a project of ours of DSC-VIT. We have a paste bin. So let's go to the DSC-VIT.ia. Sorry guys, I entered the wrong URL. Okay, I entered the wrong URL again. Okay, so we have this thing, and let me open the network tab for you guys. Okay, I have the network here. So let's type in something, and let's say this is a paste bin. So while saving this request, I am gonna be making an API request to the API server. So let's do that. Let's make a hello world paste bin. Okay, hello world, and then I'm gonna click on save. And we can see that the front end is making a request. The front end has made a request, and I have gotten a response. We can see in the response tab that message this was successfully used to make a paste, and we have a paste ID here. And this is how basically a front end works. Front end and a web app works. So a web app is going to be sending requests when you click on some button, and it's going to interact with the backend to make some APIs and some API requests and do the needful. Okay. So does anyone have any questions right now? I'm looking at the chat of both YouTube and Teams, so I'm going to wait for some questions since there is a lag on YouTube. So you guys can send me your questions. So guys, any questions you have, you can put it in the chat. I'm looking at both Teams and YouTube. I think no one has any questions, so let's go ahead with what is HTTP. So let me tell you about this first, guys. Guys, you might have seen in the previous slides I talked about this HTTP thing. What is a HTTP request? So let me tell you about it. So HTTP stands for Hypertext Transfer Protocol. What it is used for? It is used for communication between a web browser and a web server over the World Wide Web. So HTTP follows a request response model. What is a request response model? A request response model is when you are sending a request to a web server must respond back with a reply. That is a request response model. Okay, so a request response model, I told you what it is. Now let's go ahead with what is a HTTP stateless protocol. I'm saying that HTTP is a stateless protocol. You guys may not know what a stateless protocol is, but let me tell you about it first. So HTTP, a stateless protocol is something that says that when you're making a request, the server is not going to know what is going to be the identity of the request. The identity of the request is not known to the users. So suppose that you are logging on to your bank account, Okay, so in the bank account, you sent a request for knowing your balance. You got to know your balance, and the bank account says, okay, this is your balance. Now you want to make a withdrawal to your balance from your bank account. So when making the request to bank account for the withdrawal, the server is not going to know if it is the same person who the HTTP request is from the same person who previously tried to ask for the bank account, the balance of the bank account, and the person who is trying to make the withdrawal is the same person. So so this is what it is. The stateless protocol, because of the statelessness of the HTTP request, the bank account server is not able to differentiate between the two requests, the one sent before, the one sent after. But we play some tips and tricks on this HTTP request, and we give state to it. How do we do it? It's through cookies and sometimes through headers. We pass in our identity in the headers, or we pass in our states in the cookies. So these are the two things that we do to tell the server about who we are and the state of the HTTP request. So now let me show you how a HTTP request looks like. This might be exciting for you guys. Let's look into it. So we can see that there are like a few sections in this. I'm going to tell you about the sections. HTTP request will always have a HTTP method that here is the post. There's going to be a path. There is like /submit, then there is a HTTP version that here it is HTTP 1.1, and then there are these host of headers, host, content type, accepted encoding, accepted language, connection. All these are headers. These are called HTTP headers, and then there is the message, and then this message part is called a body of the HTTP request. Now let me tell you about what is the use of all these sections. So HTTP, I told you about what is methods. I'm going to give you a more broader perspective on this. What is HTTP method in the next few slides. But for now, I'm going to tell you this HTTP method is going to tell the server about the intent of the request. And then there is a path that uniquely identify what resource we are trying to access. Maybe we are trying to access on Facebook. Maybe you are trying to access someone's profile. Maybe you are trying to access someone's Facebook page. Maybe on someone's message, and maybe in that message you are trying to send someone a message. What should be the message? That part is going to be sent in the body. What message you are trying to send to someone? That part is in the body. It's the message part is basically the content that we're trying the server to understand and do needful that it should do. That it is. Now we have HTTP version here. Now HTTP version is something that we will not be covering in depth in this session, but what I can tell you about is that HTTP had various versions throughout these years. Hello. The most commonly used right now is HTTP 1.1, and you will be seeing it mostly in the places, but there is also this upcoming technology for HTTP 2 and even HTTP 3, but HTTP 2 is also not that widely used right now, and the change is happening at a rapid pace, but still most of the people right now is using HTTP 1.1. Now let's look at HTTP response. How does a response from a server looks like? Now, I'm going to tell you about the sections first. What sections of HTTP response? HTTP response has a HTTP method, then HTTP status code, then a few headers, and then the message body. The message body is the same that the message body tells about what the server is trying to tell us about the state, these are the various details about the request, basically. So this is it. And headers, these are the headers that the server is sending us back. So we can see that some of these headers make a lot of sense. There is date, that this date signifies when the message was sent back. There is a status code, for example, the header is 404 not found. That is the resource we were trying to access is not available right now. It is not there present on the server. Similarly, there is HTTP 1.1. And there is a server, HTTP 1.1, I told you about its HTTP version, we will not be covering in depth. And there is server. this server part tells us about which type of server we are trying to interact with right now. So this is it about HTTP response. Now let's look at HTTP methods. I told you about, we will be covering this in depth. HTTP methods tells us about the intent of the request. There are various intents. Sometimes we want to fetch a request. Maybe we want to delete a request, delete some resource, and we maybe want to update some resource. Maybe we want to create a resource. So all these actions and the intent for the request is going to be delivered using the HTTP method. So let's say you want to read a resource, like what a resource is, what are the details about the resource. For example, let's say you want to see the profile of some person. At that point in time, you're going to make a GET request because you just want to read about some resource. Similarly, you want to update your profile, then you might want to use a patch request. Okay, maybe then there is a post request. Then post request is used for creating a resource. You want to create a Facebook post, then you want to delete a Facebook post, then you use a delete request. Similarly, you want to replace entire post with a new post, then you want to send the entire fields with the request, then you use a post request. So TS is asking on the chat that what is expires in time in the HTTP response. The date seems to be 1970. Yeah. So I did not tell you about the expires time. So expires here is the 1970 1st Jan. It's the Unix epoch time. That is the default timestamp. That is like timestamp of 0. This signifies that this request is never going to expire. Okay, so now let's gonna go with HTTP response status codes. What are HTTP response status code? We saw that each and every response had a status code. So now let me tell you guys about HTTP responses. HTTP responses can be of various types. I'm going to tell you about some of the responses. Like maybe we just saw 404. A 404 response code is when a resource is not found. A 200 status code is when everything happens successfully. A 301 is when the resources URI is changed to some new URI, and a 403 happens when the access required to access a resource is higher than the access privileges of the user trying to access a resource. Let's say you are trying to update someone else's profile details using an API, but you are authenticated as yourself, but you're trying to update your friend's profile details. That should not be allowed. So at that point, you're going to get a 403. Similarly, when, let's say, if there is some really bad things happening to your server, at that point in time, you might get a 500. Let's say you're typecasting something null into an integer. That is an error, and you're doing it in your code. So at that point in time, you're going to get a 500, and all of the backend developers never like a 500 in their response sheet. Like whenever they see logs of the request, they never want to see a 500. I'm going to tell you that. So it's a quiz time. So let's have a quiz. So what do you guys think? Which of these stacks cannot be a part of any backend stack? So I'm going to wait for your replies right now. So you can send me on YouTube or on Teams. I'm waiting for that. So let's see who gets it first. I will tell you guys the answer once I have some more replies on YouTube and on Teams. I think Vaishnav is on the right track. Let's go ahead and see if someone else can also jump in. Come on, guys, fast. I'm not seeing any replies on YouTube as well. And Teams people are very active. Yeah, people are close only. Hmm. Sorry guys, I think I should tell the answer now. Yeah, so Game New is right on YouTube, and Vaishnav and TS are right. It's the React Native app that is cannot be a part of any backend stack because it's a front-end technology. The React Native apps are used to make mobile phone applications. So we are not using it in our backend stack. We cannot be using it in the backend stack. How we can use it? So let's say let's go ahead with DBMS software. What is a DBMS software? I showed you a database management in my diagram in the previous slides, but now let me show you about what is a DBMS software. Okay, so before I start with DBMS, let me tell you about what is a database. A database is a collection of information that is organized so that it can be easily accessed, managed, and updated. What do I mean by that? A database is a collection of documents that is structured in a particular way so that the information makes some sense. Okay, so what does a DBMS do? DBMS stands for Database Management System. Database Management System manages that database. It is responsible for effectively and efficiently doing these tasks of retrieving the document, retrieving a particular record, adding a record, deleting a record, updating a record. All these things have to be done in a very short delay, latency, with very less latency, and it has to be done effectively to maintain the consistency of the database. What do I mean by consistency is, suppose I'm trying to make a transaction. I'm trying to send my friend some money, and while I'm trying to do that, a database must follow a series of steps to complete that my command. Like what I'm trying to do, the database must do a series of steps. So for the transaction thing, so first it has to read my account balance and check if I have the required money to send that much amount. And if I have the money, then it has to go on and send that money, deduct that money from my account and add that money to my friend's account. So let's suppose there is a power failure at the point where the database is adding the money to my friend's account and the whole system goes down. But so when the system restarts, the database must start from the point where the money is not deducted from my account. That is how it should maintain the consistency of the database. This is a very important concept. For these things together are called transactions. A transaction must happen in its entirety. That is, together everything must happen together. So now I have told you about this. So let's go ahead and look at some types of database. What are the different types of database that we are using? A few of the types are relational database, a NoSQL database, a graph database that we are using every day. For this session, we are particularly focusing on relational databases. But depending on the use case, you might also have to use someday NoSQL database or graph database. So let's jump in and look into what a relational database is. A relational database stores data in forms of tables and rows. You can see it in this image that this is a table, and the table has information about populations of different cities of United States along with their state abbreviations. In this database, you could see that we have stored data in a structured format. We have given a type. We must have given a type for the name, state abbreviation, population, to everything. So we must be telling these things to the database management system in some language, some way to communicate. The language we are trying to communicate with the database is SQL. We are using SQL to communicate with the database, and when we are trying to tell the database about the structure of the data, and we are trying to modify the structure of this data, we are using a class of statements that are called data definition language statements. When we are trying to insert some data or manipulate the data present in this database previously, then we are using some class of statements that are called data manipulation language statements. So this is a brief introduction into relational databases, and we will be getting to know more about these when we are going to be using this in our project at the end of this. So let's go ahead and look at some relational databases. What are some popular relational databases? Some of the popular ones are MySQL, PostgreSQL, Amazon Aurora, Oracle SQL, IBM DB2. These are some popular ones. And for this session, we are going to be using PostgreSQL. So it's quiz time, guys. So I'm going to ask you this question. So which of the following is not a relational database? You guys are free to Google this message and tell me an answer. So I'm waiting for your replies on YouTube and on Teams. So guys, go on. I'm looking for your replies. I can see some answers coming in on Teams. YouTube people, you need to answer some things. Yeah, Prakhar is right, and TS on Teams is also right. The right answer is CouchDB. It's a NoSQL database. It also has option for key value pairs, like to store key value pairs. It's a NoSQL database. So let's go ahead and let's get started with some code. So what are we building today? Let me explain it to you what we are trying to build today, and then we'll pick up from there. So for the first thing I'm going to tell you about that we are making HTTP web APIs for a blogging website, which has the following operations: creating a post, fetching a post, updating a post, and deleting a post. The tech stack that we are going to be using is FastAPI and PostgreSQL. We are going to be doing all the basic CRUD operations on our database using FastAPI, and we are going to be using SQL Alchemy as our ORM. I'm going to tell you about what an ORM is in a while. So let's get started with that. So the first thing that you guys want to go for is this this GitHub repo. We are going to be putting the link in the chat. I think the moderators will put it in the chat. Even then, I'm also just going to put it in the chat for Teams. Okay. You guys can visit this link. I think, guys, have all of you opened this link? You can reply me on Teams, and also we have to install Postman after this, if some of you guys haven't installed it yet. So have you guys installed Postman? I see TS says here yes. So do you guys have Postman installed? Depending on that, I will just give you a brief intro of how to download it. I'm looking on YouTube chat as well, so please reply, guys, on YouTube and on Teams as well. So, guys, please. Uh, okay. So, guys, you guys have Postman installed or not? Nobody replied to me on that. So this yes is for have you guys opened the GitHub link or for the Postman thing I asked? Okay, cool. So I guess okay. So you guys are installing Postman right now. Okay, so by that time, some of you guys are downloading it. I'm gonna tell you about what to do now and what to do next. You can simply clone this repo, or you can just download the zip file and extract the zip. So for demonstration purposes, I'm going to just download the zip, and I'm also going to just extract it to some folder. Okay. So I have to use the CLI. Sorry. Okay, so I have my files here. After downloading the zip, I have everything here. So similarly, you guys must download this zip or clone the repo and get to this folder. And from there we'll pick up. So are you guys with me? You can reply if you have downloaded the zip and you have everything ready here. Like Postman thing, you can continue as we go. So for now, just complete this as well. Are you guys with me up till here? Guys, you can reply in the chat if you are following along up till now. Okay, you guys have downloaded it. Okay, cool. Okay, so now let's install virtual env. The next thing is we are going to have to install virtual env. So we need an isolation layer so that the dependencies the dependencies that we are going to install right now for our FastAPI project has to remain consistent every time, because a small change in the dependency later can break the whole thing. So using a virtual environment lets us fix the various pip packages versions, like whatever pip packages we are going to install, their versions we are going to freeze and keep it in a requirement.txt file. And whenever we need it, we are going to make a virtual env and we are going to install it. So first thing is, we already have made a requirement.txt file to make these things easier for you. But now we have to install the virtual env, make a env, and then install the requirements so that we can continue with our project. So let's do that. Pip install -r. Oh, sorry, I have to install virtual environment first. Virtual environment env, virtual env, pip install virtual env. So if we can see it in the repo, this is the command I'm gonna use right here, virtual env. Okay, and now the next command I'm gonna use, let me open my terminal. And, okay, here I have both of these things open, and yeah. So this is the command I use: pip install virtual env. The next thing is virtual env.env. Here I'm creating an env. So virtual env. Okay, so the env is now created. Now I must activate this env to use it in this terminal. So I'm going to do that next. Source for Linux PCs and Unix users. This is the command that they have to use. Source env bin activate. My env is activated. Similarly, for you guys using Windows, you have to use this command: env scripts activate. Cool. Let me know if you're following along up till here, and then we can continue further. Okay. Are you guys done till here? Let me know in the chat. Yeah, cool. So now we are going to install the requirements. So So to do that, we use the command this pip install -r requirements.txt. Pip install -r requirements.txt. Okay. Since I have most of the things installed, it's happening very fast for me. For you guys, it might take some time. Okay, so all of these requirements were installed for me. Now let's go ahead. Okay, so this much is installed. So next thing is we open this in an IDE. So I'm going to use PyCharm, but you guys are free to use any of the IDEs. Why we are using Postgres is not that because Postgres is one of the most commercially used databases. It's going to give you a very nice exposure to what most of the people in the industry are requiring right now. So when you're using Postgres, it's going to help you out when you're developing like really scalable softwares. And also the Postgres has many more features than many other databases. So you have various types, primitive types, I should say. Let's say you have a data type for IP addresses. You have a data type for arrays. You have a data type for MAC addresses. So for any need, Postgres has a solution for you. So you guys can go ahead and read it in the documentation. But Postgres has so many features. It has performance tuning as well. So let's not get into that right now. If you guys are interested, guys can message me on Telegram on our DSC-VIT channel, and we can have very nice chat on it. So for now, let's go ahead with this one. Good. Now we have virtual env installed. Okay. So now let's go ahead. We can see here there's a print statement. Okay. Okay. So is my screen visible to everyone? And everything looks good, and the font size is okay, I guess. Now also I have to. Also, I want to tell you guys about the documentation of FastAPI. The FastAPI documentation is really good. So we are going to be referencing it at times so that you guys are also familiar with the FastAPI documentation. And we have linked the documentation that we will be referring to here in the references of the repo. So you guys can also follow along. Okay. So here we have the FastAPI. We're gonna make some very simple APIs returning just the responses and just check it out how things are with FastAPI. Okay. So the first thing, let's initialize an FastAPI app and let's make a simple route. Simple route just says that says hello world. Okay. So okay, I'm gonna import from FastAPI, import FastAPI app, FastAPI, and I'm gonna make app.get. You can see that I added app.get here. This signifies that I'm gonna be making this route for a GET request. What is a route? I'm gonna explain it to you right now. Let's complete this function first. Def. We added a decorator for app.get, then we make a function below it. Okay, so let's say home route. And we just have to return what we are trying to send to the user. Let's say hello world. There's a type. Reformat this file. Okay. Now to run our FastAPI server, we are going to be using something called Unicorn. So UVCon. We are not going to use UVCon. We are going to use UVCon. UVCon. We have referenced it in our repo that we're going to be using this command to run our project. Okay, UVCon main.app, and we are gonna use reload as well. So what is this command? I'm going to explain it to you. UVCon is a tool that we use along with FastAPI to run FastAPI servers. Okay, and the next two parameters are the module name. Here it's the main that houses the main FastAPI app. We initialize a FastAPI app here and we reference it here. Inside the main module, reference the app variable. That is what this command signifies. Inside the main module, reference the app variable. And then this reload command says, okay, listen to any change that I'm going to make in these files and replicate the same change on the server. Restart the server anytime you face any change and that you see any change. So I'm going to add another route here and I'm going to show this how this is reloading every time I'm adding something to the file. So I'm going to add another get route. I'm going to say home to, and I'm going to make it def home to return home to. You see, the server got shut down and we started the server again. This is what the UVCon does when you add a -- reload to it. Okay. Now the next thing is what we can see the first statement, UVCon running on 127.0.0.0 and :8000. What is 8000? 8000 is a port. What is a port? Every process running on a PC is assigned a port when it is trying to communicate over the internet or to other devices over the over a TCP network protocol. So let's not get into TCP, what is TCP and how it works. But for now, all you need to understand is every process is gonna have a very particular number assigned to it. That is the port, and it is gonna be accepting connections to the server using this port. When we want to make a request, we must specify this port, and this 127.0.0.1 references my machine. What is my machine's name? Because google.com is Google's machine. How I'm gonna know on a local network when I'm isolated without any internet? How I'm gonna reference my own machine? We are gonna use this number 127.0.0.1 to reference my own machine, and the port number is gonna be what we assign. By default, UVCon takes in as 8000 as port number. But if you want to change the port number and specify something of our own, we just pass in a flag that is port 8080, and we just put in the enter, and we see the message unicorn running on this with the port number 8080. So this is how what is a port is. So let's use the default port for now, only 8000, and let's test out our routes. So let me close what we had previously open. And now, okay, let's go ahead. HTTP 127.0.0.1:8000, and we are just gonna send this request. See, I have sent a GET request here, right? And what is the message I'm getting? Hello world. Okay, what was this route? This was just the home route. The path is this /. Now you guys must be thinking, what is this /? What is this forward home? In my slides I told you about something called paths. I'm going to show you again. In this HTTP request, I showed you this /submit. I told you that this references the resource I'm trying to access. So even on this JetBrains page, when we are seeing /, we are trying to say that, okay, go to the resource that is just /. So when we are not referencing any paths, there is a / by default in here. So okay, it's still going in. Now I'm gonna reference to the page that is /home2. I'm gonna trying to access the resource home2. So I'm gonna reference this resource. I'm gonna add home2. Okay, and I'm gonna get message. Okay, this page is home2. Okay, do you guys know about JSON? JSON objects. You might have come across it while doing front-end development or seeing some APIs in general. JSON objects are very easy to use, light and portable structures. Like they are defined, they have a defined schema, and they are unwrapped using some libraries. But I'm going to just show you what a JSON object looks like. A JSON object might look like this. CADBin. I'm going to just open it again, CADBin. I'm just going to add. We see that the response from this will be a JSON object. Okay, this is a JSON. This has a particular schema. This there is going to be, for a JSON object, there has to be a key and there has to be a value. A JSON will contain key and value pairs, and a key must always be a string in a JSON object, and a value can either be an integer, a float, a boolean, or a string, or an object itself. Okay, an object itself, I mean, by object itself I mean, okay, this is going to be a very valid thing. I'm going to show you an example. Okay, so if I have something like this, profile, and I'm gonna have this again, name Mayank Kumar, and I'm gonna add an age. This is very much valid, since the only difference is here the value for a key is another object itself. Okay, so this is what I was trying to explain to you. Okay, so, and here we can see there is an age field, there is a name field. This is how it is, a JSON object. So with FastAPI, while returning these JSON objects, you don't need to do any black magic or any much of efforts. What all you need to do is just return a dictionary, and whatever the message you're trying to send. Let's say I'm just gonna try to send the same message, profile, and I'm gonna send in another dictionary inside it. The name is Mayank Kumar and age. here 20. Okay, and I'm just gonna save it. Okay, we saw the server is running again.
Guys, sorry for the problem. We'll just wait for a minute. My uncle will be joining back. Has some network issue, I guess.
Sorry guys, that was a network error. Sorry guys for that. And I'm gonna screen share my screen again. Okay. I guess my screen is visible again. Sorry for that. So I was here on the post screen. So I'm gonna do that. Okay. I showed you guys what a JSON is. Now I'm going to show you how to make this API request. We had returned this object, this dictionary in our home route, and we were testing it. So I'm going to test it again. I'm going to show you again. So this is at the home route, just the / path, root path. I'm just going to send in the request, and we get this response. The response I showed you before. The profile, the name, the age in the dictionary. So this is how simple it is to use FastAPI. You don't have to wrap or unwrap it. It's very simple. Suppose you might have seen on LinkedIn, there is something called in / there is your username. Let's say my username is Mayank K2. Okay, so this is my username. Now let's make an API that fetches this mayank.k2 and replies back this ID to you. Okay, so I'm gonna say in / and I'm gonna say username. Okay, and I'm just gonna type in that username is a variable. So to say to the FastAPI server that username is gonna be a variable in our URL path, we just use this name and we return this. How do we return? We say ID is username. Okay, and I'm just gonna restart the server and I'm gonna send this request. Okay, the ID is Mayank Kumar 2, and let's say even Mayank Kumar, if I go with, it's gonna change with whatever you're sending in after the in. Okay, so this is how you take a parameter from a URL. We're going to be using it in our app, and then it's going to get clear to you. It's going to be more clearer to you of its use cases. Here I'm going to show you a very simple example that I'm sending in the name and I'm getting it here. And this is how LinkedIn gets your username and just queries their database to get your profile and just show you your profile. Okay. Now let's go ahead. Now, so I have showed you till here. Now let's go ahead and get us along with what is an ORM and how to use SQL Alchemy, which I said was an ORM. So let's do that. Okay. Now let's create a file. Let's call it database.py. I hope you guys have installed pgadmin, pg Postgres server and pgadmin. So let's log into our pgadmins. So the pgadmin address is localhost 5555. Okay, I guess I know the problem. Local, so this is only a problem with my PC. I guess this will not be a problem with you guys. Okay. Okay, so let's log into our pgadmins now. My pgadmin is up, so I'm just gonna log in. Okay, so I am logged in, and we can see some servers here. And let me log into my server. Okay. I will have to add So I'm connected to my database. So you guys must have servers inside it. So a server is a general database server. You guys must also have this server with you. And the next thing is, inside a database server, you're going to have various databases. Right now, all of you guys are going to have a normal Postgres database. Inside a Postgres database, you're going to have public. Inside the public, you will have tables. Tables, right now I have something, but let me delete this, because we don't need any tables right now. So tables for you guys, it's going to be empty probably. So let's go ahead, make the table from our ORM, and then let's look at this again. So what is an ORM? I told you about relational databases. Relational databases store data in forms of tables. In tables, we have rows. Each row is going to be represented as an ORM maps a class with a table, an object of a class with a row of a table. Okay, so let's say if you have a users table where you are storing all the users of a particular program, and a class will map it to the table of users, and then the objects will be the user objects. In our case, we are going to make a post table. Post will have a title, a description, and an ID. And the objects of the class that we're going to make are going to reference those each rows. So let's start with the table first. So from SQL Alchemy, because we already have SQL Alchemy in requirements.txt, you guys can just go ahead and straight away import SQL Alchemy. Here, this documentation is going to help you out that we have put in here. So let's open this. Okay, let me open this in a new tab. Okay, so here are some imports. So let's import all of these, and let me explain it to you what these are. Okay, the first thing here is gonna be create engine, SQL Alchemy create engine. Okay, so what is a create engine? I'm going to tell you, but before that we need to have a database URL. What is a database URL? While we are trying to log into a database, we need to specify the server's location and the username and password we are going to use to authenticate ourselves to the database. How is the database going to know that the person who is going to try to make the changes to the databases is an authenticated user? For that, we need to specify the username and password and the database we are trying to access in the database URL. So let's do that first. Now, the URL scheme, we have referenced it in our database, so in our GitHub repo. So we can see that the first thing is Postgres : username, password, host, and port and DB. As I told you, the port here is going to be the port the database is listening to. Every process is going to have different ports. So the port for the server that we are going to be running and the port for the database are going to be two separate port numbers. Okay, so the port that the Postgres listens to by default, and considering that you guys must have also installed the Postgres on its default port, it's going to be 5432, and the host is going to be in your local machine. So we are gonna reference the host with localhost. And the username and the password is going to be, we're going to use the default Postgres password, and you guys must have installed that. While installing the Postgres software, you must have given it a password. You have to use that in the password field, and the user is going to be just Postgres. So let's put in this, just copy this URL and we will fill it here. Okay, so the user is going to be Postgres. Okay, and the password, for me, I just entered password only. Host, let's put in host as localhost. Port number is going to be 5432 and database is Postgres. Okay, we are going to use the default Postgres. Okay, now what is an engine? Now this create engine will help us create an engine, but what is an engine is one of the questions. So while creating an engine, you must know that any database, like while communicating with the database, every database is going to be communicating using different methods. Let's say there is a type of varchar on one database, and it is represented in a certain way in Postgres in its code, and in a different way in MySQL. So the ways of representing it in the communication between me and the database is going to be different. So an engine, using the URL itself, because you can see here we have said, okay, this is a Postgres URL. So the Postgres URL is, the engine is going to read that, okay, it's a Postgres URL, so I have to use this communication method. Okay, so let's go ahead and create an engine now. The create engine is not going to take any parameter other than the database URL. For now, at least it's going to take only a database URL, but there are many more parameters, but we are not covering that right now. Let's create this engine. Okay, we have created the engine now. Okay, now let's look into our documentation. Let's copy the next line. Okay, so the next line is using the method session maker. I'm going to tell you guys about what is a session. A session is a connection between you and the database. That is a connection. That is a session. A session establishes a connection between you and the database and keeps it established during the duration of the whole transaction, like whatever instructions you are trying to give to the database and whatever response you are trying to get from the database, you're going to do that over a session, and it's going to be established until the entire the program is terminated. Okay, for this, let's take an example, and that will help you guys out. So session local is going to create a session session class that we can use. Here it's an higher order function. It's going to make a class, so we can use it to create session class objects. Okay, so the next thing is declarative base. I told you guys about an ORM. An ORM is going to be a table. It's going to be in a class mapped to a table. So we have to create a class posts, and it should have fields like title, description, and ID. So let's create that now. To create that, we need to create a base class. To tell the SQL Alchemy that this particular class has to be treated as if it's a class mapping to a table, we must use declarative base to create a class that can be inherited. So we create a base class, base from declarative base. Okay, now we're going to create a class post, and it's going to inherit from base. Okay, and it's going to have template, table name. What should be the table name here, guys? It should be posts, and the table name is created. Now we need to create the various attributes: ID, title, and the other thing is ID, title, and description. So let's how do we make a column in SQL Alchemy? We import this from SQL Alchemy, import column, and the next thing is string. Okay, now we say title, column, and it has to be a string. Okay, there is going to be a description, column, string. There has to be an ID, there has to be a column, and the column has to be of type UUID. How do you get UUID? UUID is very specific to Postgres, so we have to import this type from the SQL Postgres dialects. When there are types that are very specific to a database, there are something called dialects that we use. So from SQL Alchemy dot dialects Postgres import UUID. Now this has to be a UUID. It has to be as UUID true. We specify as UUID true because so that if there is a string that is not actually a UUID but a string representing a UUID, then also they are typecasted to UUID. What is a UUID, you might ask? So a UUID is universally identifiable identification number. So it's a 128-bit number which can be hashed as a string as well, like based on hexes. So this is a UUID, and it's actually very unique for every time you create one. So now let's create a primary key. So this should be the primary key. What is a primary key? For every row inside a table must be uniquely identifiable by this ID, right? Because there should not be any column, any row with the same IDs. Let's say I create a post and you create a post. Both of the posts cannot have the same ID, because if I try to create and delete my post, then your post will also be deleted. That is not right. So there should be a primary key, and the primary key should be unique for every post. Now we have to create an index. This index is related to like performance tuning, which we are not gonna cover in this session. If you guys are interested, we can have a talk on it on a Telegram group. So let's skip this one out. So the next parameter is going to be default. The UUID are like 128-bit string, and the job for you to create a UUID is not something you would want. So we use a function that can automatically generate UUIDs and pass in the default, and the default function will automatically generate a UUID. How do you get that function? We get it from the UUID package. From UUID import UUID4. Cool. So we just pass in here UUID4, and we just give it till here. And the next thing is we give the command that, okay, create this database, create this table, create these columns. We say that, okay, do every change that I have made right now. To make that command, I have to write this statement, base.metadata, create all, and it's gonna be engine. Okay, this will say to SQL Alchemy, okay, create this table and get done with it. Do everything. Okay, now we will run this. Okay, now we will run the script, database script. Let's run this. So I'm gonna use Python database. Okay. Okay, so we have created this. Now let's go ahead in our PG admin and look at if we have something here. Okay, there is a table now. What are the columns? There are 3 columns: ID, description, and title. Okay, so now we have the 3 fields inside this table. We have 3 columns inside this table, and this is very much intuitive. Also, I told you that a table have columns, so we just made a columns here and just specified the type, the various parameters it might have. Now that's it. So that's done from this side. Now, what if we are going to do the CRUD operations on this table now? So now let's start with creating a post. How do we create a post? So we make this. I'm going to say a post is equal to post. So this should have been posts. Okay, because it's a table, it should be plural. It's a collective thing, na? That's why. So we make the title. We give the post our title. So let's give this title my post. Now let's give me description. Let's give it a description, and it's gonna be this. Description is equal to my description. My description, and now let's add it to the database. But before we add it to the database, I told you guys that we have created a session local. What is this session local? A session local creates a session. We need a session right now, guys, now to communicate with the database. So we create a session object. So it's going to be db equals session local, and we make this session. So the session establishes a connection between my program and the database. And I'm gonna just say, okay, in this database DB session, just add this thing, this add post. Okay, and now I need to do db.commit. What do I need to do db.commit? db.commit is has to be done because I have passed in auto commit to be false. Auto commit is something that is related to transactions, and we are not covering it in here. But for now, for your understanding, I'm going to tell you a very brief introduction of what a commit is. A commit is writing the changes to disk. A disk, what is a disk is the files. Okay, so in a database, after you have made some change, you must commit the change so that those are written to the disk, to a disk. Okay, so this is what is db.commit. Now let's run. Okay, so Python database, I have added to my post. So let's go ahead and check if we have the post in here. So I'm gonna go into the post and I'm gonna say, okay, view data all rows. Okay, my post is created. I can see it here, and it has a unique UUID. So the UUID was by default generated by this function that we had passed in UUID 4. We can see that. Nice, we have added a post successfully. Now let's do something. Let's add some more post to description to. Let's add this so that we have some data in our database to work with. Okay, now let's make it 3. Okay, 3. Okay, now we are done with this. The next thing that we do is list all the posts of a data in a table. So let's go ahead with that. db.query, because we are making a query, to what table? To post table, and we get all. Okay, and I'm gonna get it here. It's gonna be posts from table, and I'm just gonna iterate over it. And I'm gonna print I dot title. Let's print just the title for now. Okay, and I'm just gonna run this. Okay, I got my 3 posts. I had right now. I had inside this database. I have 3 posts, and I can see the 3 posts here. Okay, well enough. And now let's just get ahead, and we now know how to list all the posts inside a database. Now let's go ahead and write a query to update a post inside a database. So for that, we make an update query, and the update query should have a dictionary. A dictionary should have key value pairs. The key of the update query should be from the class that we created. The key is the class. The key should be these attributes. No? We need to update the title. We need to update the description. So what we do is we reference it from here itself. The posts dot title. Okay, and now what should be the new title? Now let's say I'm gonna do it updated description, updated title, and what should be the description? It should be the post dot description, updated description. Okay. Now we're gonna run this query for a particular post. Okay. But before that, we will need the ID as well, because we need to update a particular post. So db dot query, and I'm gonna query the posts, and I'm gonna filter the post. Filter for ID is equal to let's get an ID. Okay, now we need to update it, and we pass in our update query. Okay, let me update the name. Okay, now after this is executed, I want the database to commit the changes, because I have made some changes. Now I need to commit it again. Okay, now this much is done. Now let's run this. Okay. I think it should have been by underscore ID. Okay, let's look into our documentation. What should it be? Okay, it should have been the model dot should have been the post dot ID. So it should have been this post dot ID. And I have to compare it. Okay, now I'm going to run this. Okay, now we have compared it to this, and now let's check our database. Okay, we can see that we have a row updated title and updated description. Okay, so we selected this UID, we compared when the post ID is equal to this, and at that point we updated our using our update query. Okay, and after that we committed our changes. That is how we do it for the update query. Now the next thing is now we have created it, we have read it, we have updated it, and now we must delete it. Now we write the command to delete a post. So we do db dot query posts dot filter post dot id is equal to. Now let's put in the same id, and it's to delete a post. It's as simple as saying delete after this. Okay, and now we must commit the changes again. db.commit. Okay. Now we go ahead and Python database delete. Okay, now we just run this again. Okay, we saw our post is now deleted. It's gone. So now we have done much of the work. We have done the CRUD operations on all of these on the post table. Now let's go ahead and make the APIs or the endpoints that we're gonna need for this. Okay. Now let's go ahead and get into the requirements thing. Okay. Okay. Let me go ahead. Okay, so we are gonna need some routes. Okay, so let's go ahead and make some routes. Mummy. Okay, so let's go ahead and make the routes. First thing is we're gonna need a route to create posts. So the create post is gonna be post.create. Okay, and the route has to be post. Okay, post request. It has to be a post request, and the function should be create post. Okay, and now it should be post returning a post is created message. Post is created. The next thing is we are going to need a route to read the post. Okay, so how to get some route to that reads all the posts and sends it back to you. So it has to be a get request now. So post.get, and it's going to be / posts all list all get all posts, return posts, and we're going to return a post. Right now I'm just making the skeletons. After that we're going to write in the functions that we need for these things to work. Okay, we made a route to get all the posts. Now we must make a route to get a singular post. Get post dot post dot lead ID, as we have done it previously. We just reference it here, return post. Let's now just return an empty, and inside this let's return the ID for now. Now go ahead, let's go ahead and make a delete. It's gonna be the same path, but instead of read, it's gonna be delete. Okay, and I'm gonna delete one post. I'm gonna reference the ID, and I'm gonna return message deleted. Okay. Now we have made the route to delete. Now we must make a route to get one, delete one, and update. So update is going to be a patch request. So post dot update, and the update is going to happen, and update one. Okay. After that, I'm going to return message updated. Okay, now this much is done. Now let's run our API server and test these APIs. It's going to be uvcon main app reload. Okay, now let's test out these APIs. Posts not create, and let's send in this request. So a post is created, we are getting the message all these routes are now registered, and let's just check if all these routes are working. It has to be a get request. Let's check the get one post route. So let's put in some ID, and we can see there is some ID here. Now this is also working. Now let's check delete route. Let's put in some ID, make it delete request. Okay, deleted, it's working. Okay, delete route is working. Now update. Okay, method not found, because this should have been patch request. This is not working. Oh, because I misspelled, it should have been posts, and I need to restart and then send this again. It's taking some time, I don't know why. Okay, I think I need to reload this. Okay. Okay, so we are getting in the message updated. Now let's quickly get into this very crucial part of the discussion, that are Pydantic models. Pydantic models are really important while creating FastAPI. Pydantic models help you reference models of these ORM to response models. Okay, so what a response models is, are that when you are trying to give out a response, you need some structure to it. Like a post must have an ID, must have a description, must have a title. So you make a response model so that you can just pass in a post object, and the Pydantic models will just convert the ORM objects to responses that are properly formatted. Because the FastAPI will not know that, okay, this is an ORM object, so it should be like this ORM object has a title or something. FastAPI is not going to know that. So it must have something that it is known to, and that is known to this. So that's where we use Pydantic models. I'm going to show an example to you to make this more clear. And since we are low on time, I'm just going to copy paste some of the code now. If you go to our repo, you can see that there are two branches. Okay, there is a master branch and there is a main branch. Main branch has the code that we need right now. So inside the schemas and models, we have the Pydantic models. So I'm just going to import the Pydantic models straight away now. Okay, and let's just copy the Pydantic models. Okay, we have the Pydantic models ready. Okay, now if we see, we need a post here. Okay, we need a post here, and we need to have the database model inside this also. So database model, it's the same that we created earlier. So let's just copy paste the whole thing right now. But there is a small problem. I'm going to explain it to you what this code is. Okay, so let's start with this code. This is the part of the code that we have already used till now. Okay, so we had this in the database class, and this session maker, the base, it's this much is known to us. So right now this class is also known to us, and what this function does. Now this is something that is called and let me paste it here. This is something that is called a dependency for FastAPI. So we will not be covering this, what is a dependency and why we need it, but I'm going to show you the syntax and the reason why we need this. Okay, but before going into it, I'm going to explain these Pydantic models to you. And Pydantic models, all the Pydantic models, I told you the use case. The use case is when we are trying to return some data, we use Pydantic models for the conversion of an ORM model to a Pydantic model, so that FastAPI can know which all attributes it should unwrap into a JSON and send it back. Okay, so in this post, we can see there is an ID, there is a title, there is a description, and we can see that we have switched on ORM mode. That's what I am talking about. We need to switch on the ORM mode inside a class config. We have a delete post model, we have an update post model, because okay, while updating a post, there might be a case where the post itself doesn't exist. At that point in time, we might just want to send the detail, okay, it doesn't exist, but if we update it, we also want to send in the post. So that's when we need two of these, and we make the post thing optional, and we do the ORM conversion as well. So that much is done. So let's start with this one. Okay, so as I showed you, every time we need to communicate with the database, we need a session. A session has to be created every time. So let's say you have a million requests coming in and you have just one session, and we are trying to send every request over that one session. It's going to get very much crowded, and you're not going to understand what you are not gonna get the expected latency out of this connection, because one request is going to take time to for it to go, then come back, and then there are like many more requests in the queue. So that's something that we don't like to do. What we prefer to do is for every request we make a database session, and when the request is serviced, we destroy the session. Okay, so that's what we do with this getDB. getDB creates a session as soon as we get a request, and it destroys it as soon as we finish off the request. Okay, so the syntax to utilize this inside a route is db :session. Okay, from where do we get the session? Session is from SQL Alchemy. SQL Alchemy, as far as I remember, or it was from. Let me check it out. Let's look into the documentation. Session is from SQL Alchemy ORM. Yeah. Okay, so SQL Alchemy ORM, we just import session, okay, and then we utilize it. So we have DB session, and we inject the dependency, use the dependency. So we created a dependency from getDB. Now we also need to use the FastAPI dot depends here. So depends, and we use getDB. Okay, now we have the database object. Now we saw that from a post we have post, title, description. So we could just reference it here with this post : post. So we will get the post as a payload from the user, and we will just create a post and send and service it back. So I'm just going to copy paste the code from for this one. Now, also I would like to use some more things. Okay, so when I have created the post, I will like to give it a status code. I'll explain to you guys what a status code is. So status code we specify in this decorator itself. So we use status code. After a successful service, what status code should I send? So this is what this specifies. Status is going to be status. Okay, we haven't imported the status object, so we need to import status from FastAPI. FastAPI has a module called status. It will have all the status code that you need. So HTTP 201 created. While creating a post, we need to send back a request that says, okay, HTTP request is created. Okay, the next thing is we need to create response models. We need to specify response model. So response model for this is going to be a post. Okay. Now the response model is the post, and we can just go ahead and now copy this code. I'm going to explain it to you. We need to create the create. Okay, just like this, like the previous code in this file, we made the post here. Here also we are creating the post, but we are referencing the Pydantic models here now. So the Pydantic models will have field ID, title, and description that we are getting from the user. So this is going to unwrap, the FastAPI is going to unwrap and put it inside the post, and we are just going to read it from the post object. Okay, so the post has ID, title, and just I'm going to pass it to the post table, and from the post table I'm creating a post object, and I'm just adding inside a database, and I'm committing the change. Once I'm done with the change, I will just have to return this post object, and the ORM Pydantic model is just gonna convert this ORM object into a Pydantic object, and then after the conversion, it's going to give it back to the FastAPI, and the FastAPI is going to know what to do with it. And what it has to do is it's going to serialize it into a JSON. So I told you what a JSON is. So that's about it for the post. Now let's go ahead and finish the get route. Okay, let me show you first if the post is working. The post should be working. Let's create and let's make it a post request, and let's pass in a body raw JSON, and I'm just gonna pass in here. It's gonna have a title. As we know that we don't need to pass in an UUID here, so a title, my new post, and there's going to be a description. My description, and I'm just going to send. Okay, what is the problem? Okay, I had to stop the server. Okay, the UUID we are using here is having a conflict with this one, so I'm gonna make it. Once we have it in the separate file, this conflict will go away. So that is the reason why we are having this error. I'm just gonna reference it like this UUID, and I also have to reference somewhere else also. Okay, now this is successfully working. Now let's send in the post. Okay, now we see that the create route is working, and we have created a title and description for this, and a new UUID is assigned to this post. Now let me check in the database pgadmin, and I'm just going to run this, and I'm going to have a new post. Okay, this much is created. Now we make a route to list all the posts that we have. So I'm just gonna copy here, and since we have already made done this in our other one, I'm gonna be quick. Okay, but I'm gonna specify all the things that we are gonna need in here. So we need to specify a status code like in the previous one. So it's gonna be status dot. It's gonna be 200 right now, right? Because we are just saying, okay, the request was successfully processed, and we gonna have to specify a response model. Response model has to be a list, and the list must have a post. The Pydantic model, it is a list of posts. That's why the response model is list of posts. Okay. Now I'm gonna have to reference the DB session here. So DB session copy, and we just paste in here DB session. Now we need to just return posts. Okay, now we have a route to get all the posts. I'll just make a new tab. Okay, and I'm just gonna say posts list all, and I'm just gonna send the request. Okay, there's a syntax error somewhere. Okay, was the syntax error. I'm going to send in the request again. Okay, you can see I'm getting all the posts that are there in the database, right? I am able to get it. So this route is also working now. Okay, the next thing is now I have to do the read. I have to read a particular ID, and I have to particular post ID, and I have to return the post for that particular one, particular post. So I just copy here and just paste it. We need the DB session, so we just copy the code from above. Now we need the status and response model. So here we are returning one post, so the response model should be just post, and the status code should be 200. Okay, and we need to pass in an ID, and we need to just return the post. So the post, you are just seeing it now, how easy it gets if we are using Pydantic models. We just are returning the post. We are not making it a dictionary, or we are not unwrapping it or anything. We are just returning the object, the ORM object itself, and everything is being done smoothly. So we are done with this. Now let's test that. Post.read, and let's put in an ID. Okay, it's a get request, so we are getting a new post. Okay, we got the post for the corresponding ID, so this route is working. Now the next route is delete route. Okay, this is a little complicated, but I'm going to try to explain it to you very far. Okay, so this is the delete model. Okay, and I'm going to just copy and paste it here. Okay, HTTP to 200. Okay, delete post response, and I have the ID. Okay. The first thing I need to find if this post exists or not. The code for that is I'm gonna search for all the objects that might match this ID that I'm getting in. Okay, and I need a DB session as well here. So I imported the DB session. I'm fetching all the posts that can exist, and if not post, that is, if the post array is empty, sorry, the post list is empty, I'm going to raise an HTTP exception. What an HTTP exception is, okay, was an error. Whenever there is an error that you want to throw, for example, in this case, you want to say that okay, there is an error because I'm not able to find the object itself. So you raise an exception. Exception is a part of FastAPI HTTP exception class. Okay. Now here I'm going to specify a status code. Status code is going to be 404 not found, and the details regarding the exception. Details that it doesn't exist. Okay. One thing you should remember is when you are raising this exception, you must use the raise keyword. Returning an exception will just be an error. It's gonna be an error with the conflicting error with the response model. Okay, so you just raise an exception. Good. Now we go ahead. Once we have this post, then what we do? We just query it and delete it, like we did it in the previous database.py file. Okay. Similarly, where this now delete one is ready, so let's test it out first. Okay, go in Postman, and instead of read, I'm gonna make it delete, and I'm just gonna put in delete, and we need to change it in the message because there is a model that says I need only details. Okay, so the response should only have details. So what I do is I just make a delete response, and I'm going to have detail, and detail is going to be deleted successfully. Okay, and I'm just going to send in the request to delete. Okay, so I get the message deleted successfully. If let's say I'm going to send in some other internal server error because I did not send a valid UUID, it wasn't a valid UUID. Okay, yeah, that is the reason. No, I did not send a valid UUID. It should be a valid UUID. Okay, so this much is done. So let's UUID is not valid. So now let's go with update. Update takes in an object of post. Like you need to replace the whole post. You need to change in the if I have a title, then change in a title. If I have a description, then change the description, and give me the ID in the post itself, the post object. So that's why we will need a post in this as a parameter as well. We are taking it as a parameter, and then we are having a DB session, and then we are just going to return after update. So now first we check all the posts that match the query, that and the ID we are going to get from the post object itself. So let's check if something is found. If something is found, we do something. So if there is nothing found, then we raise an exception like we did for the delete, and if something is found, then we update that. So for that we use the update query. The update query is the same as that we used previously. So there is this post or title, then we have post that we are getting from here, and then we update the query and then commit it to the database. And then we return update post. We are going to return an update post model, but we haven't referenced it, the response model, so we are just going to reference it now. The status code should be service successfully 201, and response code is update post. Okay, cool. So this much is working. Now delete thing I showed you, and let me show you in the database as well. Okay, my new post is no longer available, and now let's try and update something. Now let's try and update my post 2. Okay, my post 2 we will update. So we'll just copy the UUID, and I will just go into the postman, and I'm going to make it post.update. Okay, now I'm just going to go and patch it body raw JSON. Okay, I'm going to say ID should be what? ID is what we copied just now, and there should be title. Title should be my new post. Updated. Okay, this is the JSON. I'm just going to update the title for now, and I'm just going to send in this request. Okay, I need the description also, because we can see that inside this post model, all of these are mandatory. Okay, and this post inside this post, all of these fields are also mandatory. That's why we need this one. Description as well. So I need this error from FastAPI specifies that, okay, in the model you are saying that you need a description, but while sending it you are not sending any description. So I need to send in a description for the post. I'm just going to send in a description. Description is updated. And I need to close it, and I'm going to send in the request. Okay, so updated successfully, and the description is updated. Now, if you see, we have done everything inside one file. Okay, but this is not the right practice. Okay, so what we are required to do here is, for reformat this, we must put the code that is related to the database in one file, one package, one module, and the code that is related to the Pydantic models into one module. So we will do the refactoring now. We will just make a Python package. The Python package will be called this database, and we have created a database. It's going to have two files. One is going to house the connections, connection.py, the connection with the database, and one is going to manage connection with the database, and the other is going to be about the models that we are going to have for the tables. Okay. Okay, so now let's just copy paste for now. We have to move this entire thing to connections. We are going to paste it here. Now there are going to be errors. There are going to be errors about everything. So we have to import SQL Alchemy. We have to import the class name, create engine. Okay, and then we have a declarative base. Okay. Now we are done with this much. Now we have to make a schema. Sorry, before making schema, we must make this model. No? I totally forgot about it. So in this model, I need this post base. Post base I have put in. Now I need to import this. So I import base from connection because I have created the base from here. Now I need to import the column. I need to import from SQL Alchemy column. Then I need to import string. import has to be from SQL Alchemy strings, right? And from UUID, I need to import UUID. No, not from UUID. I told you it should be from dialects, right? Dialects, Postgres, dialects. And this UUID4 has to be from UUID library. So I imported that. Okay, now another thing that we need to do is do the migrations. No, sorry, do the changes that we have to do. This commands help us with that. So we will put it inside the same file, and we need the engine now. So we need the engine from database connections. Okay, I'm just going to reformat now. Okay, we have got the connection now. And now inside the connection, there is one thing missing. This file should house the generator function, generator that we are using. What is the generator? Generator is this get db. So we have to move it here. Then after moving it there, and now this database package is ready. Database module is ready. Now what we have to do next is this. We have to create a schemas for Pydantic models. Now inside schemas we need to make models Python file. Okay, models Python file will house this. We have created many Pydantic models now. All the Pydantic models should be housed inside that. So copy to here, and we just paste inside the Pydantic models. So now we need to import all these classes. So it's going to be here, and import file. Option is from typing UUID. So UUID is type from UUID has to be imported from UUID library. Import UUID. Okay. There are no more errors here, so we are done here. Inside the main, we have got a lot of errors now. We need to import all of these. So the post is from Pydantic models. So first, let's remove all the unused dependencies. Okay. Okay. We need to import. So we have import from schemas, the post. We need to get the database, get DB function. So it has to be from the connections. Now another is the post. The post has to be from the models, database models. Yeah, right. So the next thing that is missing in our file is delete post response model. So we have to import from Pydantic models that we have created. Then again, the response model update post. It has to be imported. Okay, it has to be imported again. So we have imported it. The next thing, we are done with this much. So our reformatting is now almost done. The only thing that might be bothering to all of you guys is that if your database was on internet and it was being serviced, it was servicing everyone over the internet. So this putting up this URL in your GitHub repository can give you a lot of problems. So we need to solve this out. How do we solve this? We put this string there because we have credentials in here. Put the string inside environment variables. How do we create an environment variables, and how do we secure it is by using .env files. .env files. .env files. Let's create a .env file first. Then I'm going to explain it to you. The .env files takes in a parameter. This we have passed in this the env URL. Okay, there's some problem. Okay, so I have the database URL here, and env files houses all the credentials that we have for it houses all the credentials that we have for a database. So in this Wait a minute, I need to put my laptop on charge. Sorry. Sorry, guys. Thank you. So the .env file hosts all the credentials that we need. Okay, so inside the .env file we have the credential, so we have to use the credentials from the .env file, and we are not going to push the .env files to a GitHub. So the .env must always be reference inside this. So we added .env inside the git ignore so that it is never pushed. Okay, so how do we get the values from .env and use it inside our project? So we use a module called decouple. So from decouple we import config, and the config inside with config we just pass in the key name config, and the key name is database URL. If we go inside the env, we can get a key, and here there is a value. So config database, and we get the value. So if we run our server, now we have a fully complete API set ready, and it can be very much used inside with a blogging website. One thing that might be missing is authentication. We haven't covered authentication, but if you guys are interested how we can implement an authentication service, you guys can ping me up. Let's list all the posts for one last time, and let's see. Let me show you that everything is working fine. Okay, I'm going to send a request. Okay, I got all the posts that are there in my database. So this was it for the session. Guys, do you have any questions now? I'm going to take any questions that you guys might have. So thank you for sticking around for this long session. Hope you guys enjoyed it. So if you have any questions, you can put in the chat. I'm looking at both YouTube and Teams. Guys, do you have any questions? So I think no one has any questions now. Yes. I guess then if no one has any questions, the video is available. If you were not able to keep up or not able to complete everything, you guys can go through the video, and if you have any doubts, you can reach out to me on Telegram of our DSC-VIT channel. Thank you for attending, everyone. Thank you.